Okay, work energy examples. Now, in all these examples, I'm going to encourage you guys to draw the initial and final conditions because when we're dealing with energies, you need to know what the initial state is and the final state. It has to be well defined. Otherwise, it's going to be very difficult to figure out what's going on. So in this case, we have Kristen, whose mass is 40 kilograms, is pushing her little sister on a sled on a packed icy surface. Kristen's force exerted on her sister is shown by the graph below. Her sister and the sled have a combined mass of 20 kilograms. And the first question is determine the final velocity of Kristen's sister. So, a couple assumptions here we're going to make. The speed initially is 0. I know it doesn't say it, but implied we can do it. We don't have enough other information to make any other conclusions otherwise. All right, our final state is her pushing. Like after her pushing, our sister's moving. So the system is going to be the sister and the sled. All right. External to that is Kristen. And we could say the earth and the ground if we would like. They don't all have to be in there, but the key here is that Kristen is external. So initially, once we have our system, we know what we can look at here. We have no kinetic energy because it's not moving. We have no gravitational potential energy because there is no change in height. There's no springs involved here. At the end, her sister is moving. Gravitational potential energy does not change. So there's no springs, and internal energy, there is none. So, which means that energy had to come from somewhere. The external force exerted by Kristen. Kristen is doing the work on her sister. So, our equation is work is equal to the final kinetic energy. So to figure out the work here on a force versus position graph, we want to find the area underneath the curve. All right, so this is going to be 1/2 times the base, which is 6 meters, times 10 newtons, which is going to be 30 joules of energy transferred to her sister from Kristen. So we're going to have work is equal to 1/2 mv squared. 30 joules is equal to 1/2 times 20 kilograms. You got to be careful there because it's the mass of her sister and the sled times the velocity squared. Half times 20 is 10. Divide both sides by 10. We get 3. The square root of 3 is going to be 1.73 meters per second. And that is the speed of her sister and the sled.